Welcome to episode 29 of the Actual Astronomy podcast. So this is going to be a podcast on the Milky Way galaxy. And so, many people have heard about the Milky Way, but we're going to talk about what it is exactly. A lot of people may have said that they've seen it or they want to see it. But what are we talking about, Shane? Like, even in the most general way possible, what are we talking about when we say we're going to go and observe or take a look at the Milky Way when we go do astronomy at this time of year?
Well, maybe before I get into that,
Sure, yeah.
I just want to set the table a little bit in terms of timing. The Milky
Well, I
Way,
could eat.
yeah. So yeah, two things. The Milky Way is an ice cream place in Regina, which is really good.
Exactly. Yeah, that's what I was thinking.
But
you should tweet that out.
I probably should.
People think we're making this up. This is a joke only because it's working so well.
Yeah, and the Milky Way location ice cream place in Regina is quite legendary. It's been around for decades, serving.
I think you mean legendary.
Oh, there you go.
Oh wow. Oh, there's a giant.
All right. We're moving on from that. So summertime Milky Way is amazing. It is. I get lost in it every year, and I look at the same objects in it every year because it's just so beautiful. So I'm glad that you decided we should talk about the Milky Way, because we're just getting into summer darkness that will take us into the fall, and this is the time of the year to get out and see the Milky Way.
Yeah.
So.
Exactly.
The Milky Way is our home galaxy. This is where Earth and the sun, and this is where we reside. When you look up into the sky and you see stars, whether it's with your naked eye, binocular, or telescope, you are seeing only stars that exist within the Milky Way.
Most people don't realize that. I didn't put this down, but that's a really good point. I do often make that when I'm teaching about the Milky Way in my astronomy classes, because people say, well, like, how do I know if I'm looking at a star that's in the Milky Way? I'm like, they all are. You and I are like two of the few people that around here probably that have seen stars not in the Milky Way, because you hunted some down one night, and it was a pretty darn difficult exercise, if I recall correctly.
Yeah. Like you can observe some distant globular clusters that are in the Andromeda galaxy. Now you need some serious aperture. We were attempting that through a 12-inch Dobsonian that night
under very dark skies.
Yeah, and when you see it, it's really like you're not seeing another star. You're just seeing like a fuzzy little blob, and that's a collection of stars. It's just like when you look at a galaxy and you see this luminous object, you're seeing the collective light of billions of stars within that galaxy. But to see an individual star, it's Milky Way, and that's it. And so, when we say observing the Milky Way, I guess you could say any star you see is you're seeing the galaxy. However, during the summer, the core of the Milky Way is on prime display, and that's where you get kind of this banding of starlight, and really what you're seeing is this milky stream in the sky, which is how the galaxy got its name, essentially, too.
Yeah, that's what it looks like. It just looks like, and one of the things that people will ask when they're looking at it is they'll ask, is this band, it looks like a band of clouds, but it's really strange because it's sort of narrow and it runs from due south up overhead and into the north. And they say, I've been watching this for a while, because we get this frequently when we're out doing our public outreach in the national park, in the Grasslands National Park, and they'll say, hey, is this the Milky Way? And we're like, yeah, absolutely. And they're like, I never thought I'd be able to see that. I'm just going to hop in really quick. I put in this statistic from a 2016 National Geographic, and it talks about America, but which is so different, I think, from most places, that 80% of Americans have never seen the Milky Way, and they say that a third of the world's population would not be able to even glimpse it.
I'm glad you brought that up, Chris, because I take it for granted. I was born and raised in a small town in Saskatchewan, outside of Regina. And I remember quite often as a kid, we would, I might be coming home at night, after hanging out at a friend's house,
Yeah.
and you would just look up and there it was. There was
Yeah.
the Milky Way. It was no big deal.
Yeah.
But the public outreach that you and I and some of our other friends do down in grasslands really opened my eyes to, the fact that not everybody's seen it. I
Yes.
remember a number of nights, we were showing people various objects through our telescopes, and hearing comments. There's one gentleman that stands out in particular. I don't know his name. We had some brief exchanges just throughout the course of the evening. He looked through our telescopes a little bit, but he just looked at the Milky Way with his naked eye,
Yeah, I think
and
that
he
was the
said,
guy that was asking like that. Like at first, like that sort of prompting question to me or you. I mean, we're standing like 8 feet apart, so I can't recall if he was asking me or you, but I think that's the person I'm remembering as well.
yeah. And this is the first time he had seen the Milky Way. And,
Yeah.
he was retired and he was, traveling across Canada, seeing a whole bunch of national parks. And I thought, how is that even possible? But
Yeah.
again, I take it for granted. Because of our location, we don't have a lot of population or light pollution. And that's just not the case for, the majority of where people live. They often live in light polluted areas, which really, in the last podcast, we talked about why dark skies are important. Because it washes out details of nebula clusters and
Yeah.
distant galaxies, but it also washes out the Milky Way. You can't see it under any form of light pollution.
And the one thing, I guess I was fortunate. Well, I don't guess I know I was fortunate, Grant, where I grew up, and spending my summers in extreme rural Nova Scotia. Um, and we would also on those rare occasions where it was clear at night, unlike here where it is often clear at night, be able to see that Milky Way. But I kind of found it intimidating. I wanted to learn the night sky, and I really wanted to do astronomy for a long time, but there we have, unlike the bodies of water here, we have, some pretty significant tides, and we have a deck that goes down to a floating dock. And I would lie on this when it was low tide at night, beautiful like angle for looking at the sky overhead. And I remember looking into what I now know as Cygnus, and I think I probably more or less knew it was Cygnus then, give or take, or maybe I knew the Summer Triangle. I knew I was looking up into the Summer Triangle area. And I was about 13, and I was like resolving stars past 6 magnitude at that time even. And boy, I remember thinking, there's no way I could learn all these. That just seems impossible. But I remember thinking at that time, at that age, I'm really going to try to do this. And it took a few years to really kind of get my feet under me to really do that. But you really can't learn all the stars in the Milky Way. That would be impossible.
Yeah. There's no way. There's almost too many deep sky objects within the Milky Way to fully remember where they all exist and what their names are.
Yeah. So, do you want to give a visual impression of it now, like your visual impression, or?
Yeah. So if you're out under a dark sky, I don't know, anytime in July through August, really even going into September. You allow your eyes to get dark adapted. So, no white lights for 30 minutes once the sky is truly dark. And it's almost like, again, in the last podcast, we talked about noctilucent clouds and how they just they're like ghosts. All of a sudden, they just start to appear.
Mm.
And you'll notice that in the Milky Way. If you're looking, pretty much due south, you'll see this band of kind of milkiness or cloudiness in the sky that it starts at the horizon and it goes all the way up overhead. And as the sky gets darker, this band will become far more prominent. And that's the Milky Way.
Mm-hmm.
And again, under dark sky, it is enormous.
Mm-hmm.
It takes up a big swath of the sky. How many degrees is that, Chris? Do you know offhand?
Well,
I measured it.
Well, so yeah, it's kind of a funny thing, and if people recall, we were talking about sort of favorite books a few episodes ago, and one of my favorite books is called Deep Sky Wonders, as edited by Stephen O'Meara. But it's a bunch of articles put together into book format by O'Meara, and the writer was Walter Scott Houston. But he had something called the Milky Way uncertainty principle, and that's that if you look at for the Milky Way, you find it, under a dark sky. You kind of say, okay, well, like this is the edge of the Milky Way, and then you kind of go and do some observing or whatever, and you come back a short while later, and you try to find the edge again, it will have moved a little bit, because depending on the sky transparency, your dark adaptation, and some other variables, it will appear to, expand or shrink depending on these. But typically, like, when we're at a really dark site and we're having a really good night, it just keeps getting wider and wider and wider.
Yeah.
I don't know if you've noticed that as well, till finally
Absolutely.
it seems like it's taking up, like, almost the whole sky seems like it's Milky Way after a while.
Yeah. I guess it's not a fair question because there are so many variables, particularly how dark is your sky. But the other thing that is very prominent within the Milky Way is it's very patchy. There's some very patchy bright areas, and then almost like an absence of stars. You'll have some dark areas, which are known as dark nebula.
There's
most nebula. Sorry.
No, I was just gonna build on what you're saying, which is there's the Great Rift, which runs sort of almost dead center from somewhere around Scorpius to somewhere into Cygnus, and it divides that Milky Way into two. And this is actually material that's between us and all these background stars that form the Milky Way.
Yeah, when we talk of nebula, there's a couple classes. Well, maybe three classes I'll talk about. There's a star that will go supernova, so that it explodes essentially, or it sheds off a lot of its material. That is just gas that is shot off into space, and then it's illuminated by usually that star that is still kind of hanging on to life. So it gives off light, and you're able to observe it through a telescope or binoculars. Then there's other nebula, like say the Great Orion Nebula, M42. Again, it's a lot of gas, and it's illuminated, but it's a star birth region. So stars are being formed there, and they take on all sorts of different shapes and sizes, and very, very unique in almost all cases. The third class, which doesn't really get that much attention, is known as dark nebula. And the reason it doesn't get attention is because you can't actually see it. It's not illuminated, but it's dust or gas in space that is between Earth and some stars, or in what we're talking about here with the Milky Way, it's between us and the Milky Way core. So you just can't see anything there. So it's kind of a weird thing to talk about. When you observe a dark nebula, you're observing just the absence of light, and that's how you've seen it.
Yeah.
And they're all over the Milky Way.
Yeah, and I love looking at these. You really need a dark sky. They're contrast objects, so you really need a dark sky and some good wide field optics to observe them. But one of the neat things, like you referenced some of the deep sky objects earlier, like the nebulae and star clusters and such. And we have a couple different kinds of star clusters. We have open and globular clusters. Do you want to? Can I put you on the spot? And we don't have this in our notes or anything. Can I put you on the spot to describe an open and globular cluster? Because I feel you've described it before. Maybe it wasn't even on this podcast, but just when we're doing presentations, like you have a pretty elegant way of describing the open and globular clusters as well that are in our Milky Way.
Oh, the pressure. I feel the pressure. So a globular cluster is really just like a condensed ball of stars. They're often circular, hence the name, planetary. And they vary in size and brightness. The most prominent one in the Northern Hemisphere is Messier Object 13 up in Hercules. Great summertime object. Some people describe it as like a bowl full of jewels or a bowl full of diamonds, because in M13 with a decent aperture, you're able to resolve hundreds, maybe thousands of these individual stars. It's quite pretty. When I started observing deep sky objects, I loved looking at globulars and hated open clusters.
Me too. I was the same way. Yeah.
Yeah. And so an open cluster is pretty much, it's pretty much any collection of stars. It sounds odd, like globular is very defined, it's, this kind of ball of stars. And, if you look at an open cluster and a globular cluster, it becomes very evident. But Open clusters are just a collection of stars that have they're part of a system. They're gravitationally bound, or they interact upon each other,
and they have a common point of origin. Like
yeah,
they were all born more or less the same way. Like in a nebula, kind of like maybe the Orion Nebula is birthing out a bit of an open cluster right now. Maybe you could say.
Yeah. So the Pleiades is maybe one of the more widely known examples of an open cluster.
M7,
M45.
yeah. Or yeah,
M7.
M45. Yeah,
Yeah, M45.
we make some goofs. Yeah.
So that starts to appear in the fall. It'll start to rise and become more of a winter object.
Yeah.
So that has 7 or 8 prominent stars that form that open cluster, but I can't remember how many stars are actually part of that cluster. Once you put some optics on it, again, binoculars or telescope.
Yeah, dozens. Yeah.
Dozens. Yeah, it's beautiful. It's a stunning cluster to look at. The reason why I kind of hated open clusters when I first started observing is because they're somewhat challenging to find occasionally. But as you observe them more and more, they become easier to find. And now I prefer them over globulars because they're all so unique in terms of the star brightness, sometimes the star colors, but definitely like just the dispersion of the stars is always different. So now I kind of gravitate towards these open clusters, and I love looking at them. And maybe 2 other points: open clusters are generally younger stars. Globulars are some of the oldest stars in our galaxy.
Yeah, that is a good point. Just kind of sort of building on that. So we have these open and globular star clusters, and then we have the nebulae, like the star-forming regions, and then some reflection nebula and some dark nebula. And one of the really neat things about the Milky Way is, in a way, like other than the moon, this is sort of like the easiest thing to find from a dark sky. You just look for this sort of unmoving band that goes from due south up overhead, and then into the north from there. And so if you can find this large giant band of clouds, like the largest thing in the night sky to look at, and it kind of looks a bit fuzzy, it might look a little bit white or green in places, and it's bisected by this dark banding of dark nebulosity, people generally can find this. You don't really need a map or anything like that. So when I have either people in my class or people are just asking me like, gee, I'm going to be going camping or something, I'm going to take a pair of binoculars like you suggest. I have a pair of binoculars already. But what can I look at? I don't really know all this stuff, and I'm just kind of learning it or want to learn it. I'm like, look, don't worry. Just don't worry about taking anything out with you. Just take the binoculars. You don't even need to take a star chart or anything. You just find that cloudy band that runs from the south up overhead to the north, and just take your binoculars and scan up and down that, and you're going to find all kinds of great stuff. You're going to see things that are fuzzy. You're going to see groupings of stars. You're going to see some of those really round balls of stars like the globular clusters. You're going to see that bright band break into stars, and then other clouds of stars, and behind you're going to see these dark rifts and seams of the dark nebulosity that are in there. And you actually don't need to know what all these things are to start looking at them. Like you can just go and look.
Yeah, and you could spend multiple nights doing that. There's just so much to see in the Milky Way. It's absolutely incredible. 2 of my favorite things to look at in the Milky Way, they're both in the constellation of Sagittarius. One is Messier object number 17. It's known as a Swan Nebula. You'll hear all these names of nebulas, like there's the Dumbbell, there's the Swan, on and on and on.
Yeah, these are what we call common names.
Yeah. But sometimes I struggle to see the image that the name is portraying. But when I look at the Swan Nebula through a telescope, there's no denying what it looks like. It looks like a bird. Like it's incredible. So I love that one. And then
I think it looks like a loon, but
agreed. Yeah, maybe not a swan. Let's rename it the Loon Nebula.
Yeah. Well, the reason why I say that is you know how loons have that collar?
Oh, yeah.
It's got that collar
yeah,
to
you're
it.
Right.
If you look, I can't remember, anyway, it's got a little bit of a collar of stars, like 3 stars that are, anyway, and loons have that collar. We have lots of loons up here in Canada, not so many swans.
Yeah, that's true. The other object I really like is Messier 23, and I'm certainly not
Really, that's an
highlighting.
open cluster. That's sort of an off Broadway kind of pick, I would
Well,
think.
what I love about it is when if you're star hopping your way towards it, or just sort of scanning the Milky Way, it is such a neat transition from like where that object begins and where it ends. It's such a rich area of stars.
Well, now I got to go take another look. It's funny you picked that because, and it just goes to show there's no accounting for taste. No, it just goes to show that Shay and I are pretty good friends, so it's all good. But you could pick an object that would be at the bottom of my list, and then I'm like, wait a second, what? Like, I respect Shane as a good observer. I'm like, well, I'm missing something, right? And I remember this happens to me all the time. The same with NGC 7789, Carolyn's Rose up in Cassiopeia. Again, this was an open cluster. I just thought never write home about it. And then, Herschel observer Mark Bratton was out observing with us once. And he was like, "Did you ever look at this?" I'm like, "Yeah, I looked at it. No big deal." And they, no, did you ever see? And starts going on about all this stuff. And I'm like, what? How can I miss all this? So clearly I'm missing something. So what am I missing in M23?
Well, it's just the how rich that star field is, how big it is, but how defined the borders are. That's what I love about it. It's just, again, if you kind of just pan over to it, you kind of have your typical Milky Way background, and then all of a sudden things get really fuzzy and it's like very distinct.
Okay.
I
All
love
right.
it. I love it. So
that's going to be like the first object I look at now once we get to dark skies here.
So. Yeah. Notwithstanding Lagoon Nebula, like there's some beautiful things to see. Like there's, to pick one or two of my favorites probably isn't even, fair, because there's just so many great things to look at up there.
Oh yeah. Like I honestly, what I really like to do is to take like a binocular or one of these really low power, like even the 80 millimeter that you were working on that has some alignment challenges, and to put like your Nagler 31 in that, and then just on a very basic tripod, just kind of scan up and down that band, and try to get like a few objects, because you can get like the Lagoon and M20 and M21 like in the same field of view, and you put a nebula filter in and that nebula really pops out, and even in an 80 millimeter telescope. But you can see all these different objects like in the same field. And I actually think there's probably, there's a couple of globulars in there. There's a couple of other nebulae in there. There's a star clad in there. There's a big dark band in there. Like you can see like many, many objects all in the same field of view. I couldn't really pick. Like we have had so many great sessions. Like, you think, oh, like star clouds, the large Sagittarius star cloud, the small one, the one up in Scutum star cloud is so beautiful. And then when you have some dark nebula that are overlaying on them, it's just an amazing. But you know what? One of my favorite regions of sky though is there's like a little piece of the Milky Way that comes down through the top of Ophiuchus, where you have, I think it's IC 4665, the summer beehive.
Oh, okay. Yep.
And there's like a series of other open clusters. I can't remember them off the top of my head, but it's like this little band, and you can see them all really well through binoculars. And I just really like that sort of little band that kind of peels off the Milky Way and jets into the very top of Ophiuchus. So it's nice and high, and there's lots of clusters, and they're really, really pretty little clusters. You can get like 2 or 4 in the field of view, depending on the size of instrument and how much wide field you have. But yeah, I just love that. Yeah, it's just so relaxing. And it comes back, like, even though you and I have been doing this for a long time, kind of like my advice to the beginner that doesn't even know any of this stuff applies to us as well. Like, it's been a while since we've been out under dark skies, and when we get out, we kind of do just want to enjoy them. Like we like to hunt stuff down, but there's a lot of time we just like to enjoy the night sky. This is what we love to do. And with the Milky Way, we can just start panning across it with our small instruments or binoculars, or even just sitting in a chair and looking at it, waiting for some meteors to come in. It's really a lot of fun. Great, enjoyable way to spend an evening.
Yeah, totally. And when we go out to a dark sky, we do a minimum of 2 nights usually.
Yeah.
And what I like to do, especially if the forecast is going to be clear for both nights, is usually night 1, I will just look at a whole bunch of stuff I've seen in the Milky Way before because it is so much fun and, enjoyable. Night 2 I'll dedicate to searching for some new objects just to,
Mm.
provide some variance. But yeah, it's a great place to come back to. And I do have to make a correction. I was wrong on M23. When you said Sagittarius star cloud, I thought I better just double check because that's what I was referring to, and that's
Oh, okay.
M24. So
Yes,
my
M24.
apologies.
Well, now I want to. Now I've slammed M23 needlessly. So I'm gonna have to go back to M23 and give it another kick. So, but yeah, I really like the M24 star cloud. But it's a bit of a misnomer though, because M24 it's in the Messier catalog. We should do a talk on the Messier catalog or podcast on the Messier catalog
Yeah, yeah.
sometimes so people can really get the gist of it. But Messier was an observer in the late 1700s, early 1800s, and he was hunting for comets, but he ended up creating a collection of these deep sky objects, of which M24 is one. Now, it looks like this star cloud, but it's a bit of an optical thing. And what's happening is we're actually looking through like an opening in the dust and the gas of our Milky Way, and we're just looking beyond that at an even a richer part of our Milky Way. But there's not like a cloud of stars all concentrated together. It just happens. If that hole was wider, we would actually see it as much larger. Or if the hole covered most of our sky, we would just see a much brighter Milky Way. It's really something to think about. Like if you look at how bright that little patch of light is by M20 or as M24 is, which is I think a couple degrees across by maybe 3 degrees high. Imagine if the whole Milky Way looked like that. Would be something else. Eh?
Oh wow, that would be almost too much to take in. That's an interesting point because another real cool phenomena about the Milky Way, again, if you're under really dark skies, and I've shown people this on our public nights out at grasslands, is if you're in a really dark location, the Milky Way casts so much light that it throws a shadow.
Yeah.
And like, as you know, Chris, I like to record observational notes. So I'll write down what I'm seeing on a pad of
Mm-hmm.
paper.
Yeah.
And all I have to do, because once your eyes get dark adapted, without any lights, you'll easily see white paper.
Mm-hmm.
And if you just put your pen or a finger on that white paper, you will see a little bit of a shadow thrown from the Milky Way because of all of
Mm-hmm.
that starlight. And
Yep.
now, with your last comment about, could you imagine if the whole Milky Way was visible without that
Yeah.
dust there?
Yeah.
Holy smokes, would it be bright?
Yeah. It would be really, really bright. Yeah. There's a few spots that are pretty bright, and yeah, they would do that for sure. For sure. Hey, can I just like hop in and talk a little bit about the history of the discovery of the Milky Way, like
Yeah,
super quick? Because
yeah.
I wrote a bit on it. I mean, we don't need to include everything that I put in the notes or whatever. It's not really important, but I'm pretty interested in the history and sit on the history committee, so I feel like I had to put some history content in. But it was Galileo who first saw that this band of the Milky Way was actually comprised of individual stars through his telescope in and after 1610. But up until the early 1920s, most astronomers thought that the Milky Way contained all of the stars in the universe. Now, that's actually a fair assumption because, like you were saying earlier, all of the stars that we see in our sky are actually part of our Milky Way galaxy, which is our home galaxy. But it turns out there's all kinds of other galaxies out there with some have less, some have more, some have around the same number of stars that we have. And it wasn't until like the 1920s when Edwin Hubble was doing his work that he was able to show that the Milky Way really is just one of many galaxies that are out there. So it is something to remember that this is our as some have said, our island universe that's out there. We're really sort of out there floating around in the universe in our own system of nebulas and stars and star clusters and such, and that's what we are. But our galaxy, the Milky Way, is about 200 light years across, and the Milky Way is about 27,000. Sorry, I think it's 200,000 light years across, and we're just 27,000 light years from the center. So we're fairly close into the center, but we're just off the inside edge of the Orion arm. So when we're looking up Orion in the winter sky, we're just sort of in amongst the outer reaches of some of those stars. Knowing the size of the Milky Way, though, we're still over like 12 or 1,300 light years away from, say, like the Orion Nebula. I think it's about 1,300 light years away. So that's like our local neighborhood is within sort of single digit thousands of light years away. And when I was kind of doing a bit of digging, I hadn't read this before, but I kind of like this fact. So if you were trying to imagine how big the Milky Way was, you would shrink the solar system down to about the size of a quarter. And then the Milky Way would be about the size of the contiguous United States. So it is really, really big, even on that sort of scale. Yeah,
yeah, that's a great reference.
Yeah.
That does help help me understand anyway just how large one common galaxy is. And like you said, there's some that are larger, and there's an uncountable amount of galaxies out there. It's incredible.
Yeah. The one thing that some people may have seen recently, and I always try to mention this, is that there's actually a black hole at the center of our galaxy, and at the center of every galaxy that they've looked at, and this is a difficult thing to do, and they've only recently in the past sort of 10 or 12 years really been doing this. They've been able to discover that there's black holes at the center of most galaxies, but with ours they've been able to see stars orbiting around it, which is pretty neat.
Yeah, those I remember seeing that animated, the stars kind of getting thrown around and orbiting. Very cool, very neat to see.
Yeah. So let's see. Is it marked on charts?
The black hole?
No. Well, where is the center of the galaxy?
In the night sky?
Yeah, like if we were looking up, do you know where that is?
Well, do we see much of that from our location? Like, would it be down in Sagittarius, or is that a Southern Hemisphere thing to see?
No, it's down in Sagittarius. Yeah, it's just off the tip. Yeah, I know, it's like Spot quiz. I didn't put that in the notes. I ran out of some time, but it's just off the spout of the Sagittarius teapot, and it's sort of just south of, we were talking about M24. It's just south of that, by maybe 8 or 9 degrees. But there's nothing really there to see. You can just kind of point to that spot and say, that's the center. That's where the center is, because we can only see in it, like I said, about 1,300 light years or so, if that.
Yeah, no, that's interesting. And in Sagittarius, like with that with that being known, if you follow the Milky Way up from Sagittarius, it kind of starts to narrow gradually, as well as less densely packed in terms of stars, or it's not quite as bright. So, from what we see of other galaxies, the greatest collection of stars is at that galactic center, which again, you can observe just in that Milky Way band in the night sky.
Yeah. Maybe I should mention this. Just thinking about this while you're chatting here, and that since we're closer to the center than to the outside, it's this time of year during the summer months when we are looking towards the center. So that's where most of the stars are. So it's going to look brighter and denser in that direction, even though we're only able to see maybe a few thousand light years at most towards the center. That just has so many stars in it. Like I said, even through that little hole that makes what we call M24 appear as a star cloud, that much brighter. Like you could just get the sense of how many stars are towards that core. We're only just seeing a small fraction of the way towards the center. Now, in the wintertime, we actually face in the opposite direction. We face sort of out into the suburbs. So we're looking through that sort of remaining, say 170 odd thousand light years of the Milky Way, but it has far fewer stars in that direction. So we sit kind of, right at the cusp of where the stars, start to thin out pretty rapidly. And then in the winter, you can see it just to the left or just to the east of Orion, running through the constellation of Monoceros. Is a good spot to see it, and it's relatively faint. I know we were out in in the winter there in February taking a look, and we could just faintly see it from like a magnitude 5.5 side eye.
Yeah, it's certainly no comparison to the summer Milky Way, and I've imaged both. I've imaged the summer multiple times, and maybe twice the winter Milky Way, and even in photographs, they're very different. Now, you can still tell that there's a great collection of stars in the Milky Way, the winter Milky Way, but it really pales in comparison to what you can see during the summer months.
Yeah, and maybe if people are wondering what we're talking about, I should have put this in the notes, is that you have the photo on the banner on the Podbean page, and I think you've used that photo elsewhere, and that is a really great photo of the summer Milky Way that we have, and since it is one of our favorite things to look at, it's really great shot and very appropriate usage of that image that you've taken.
Yeah. If you go to actualastronomy.podbean.com, or if you go to our Twitter feed, which is at Actual Astronomy, I use the same image on both locations. And it's an image that I acquired in the grasslands using some of the steps that I talked about in our easy astrophotography episode. It's a single exposure. Really very little processing done, just adjusted a few colors or a few levels just to sharpen the contrast. But anyway, yeah, it's a neat image, and it really shows some of the patchiness and the brightness and the changing light levels within the Milky Way. And if you look at that image, kind of on the right hand side of it, there's a real prominent dark nebula. It's gigantic. It's naked eye. And Chris, this is one that you sort of brought to my awareness after going to grasslands multiple times. Do you want to? I'll put you on the spot. Do you want to talk about that a little bit?
You're probably talking about the dark horse or the prancing horse.
Yes, I am.
So this is a combination of several dark nebulae, and it looks very much like a horse, sort of with its hindquarters sort of on the south, and then has the body going up, and then a small head, and then some arms. Not to be confused with the Horsehead Nebula in the winter sky in the constellation of Orion, but yeah, like that series of dark nebula are really beautiful. And it's funny, we can actually see that unaided eye from in the grasslands. I think you've been able to see that as well.
Oh yeah. It's amazing actually, how prominent, those kind of border areas are defined. Now, it doesn't just pop out at you the way it does in this image, but it's certainly visible naked eye. Under the dark skies, like darkest of skies.
Yeah, you really need to be under dark skies in order to see it. And having been under lots of dark skies, when I go under skies that aren't quite as dark, I can still see it. But from where I spent my summers growing up, you could see that was just something that I grew up being able to see. So I was really fortunate in that respect. But oftentimes, like people will, or like documentaries or something, will talk about the stars or whatever, or our Milky Way, and they'll show a shot of that. But that area of the sky is between Scorpius and Sagittarius, and up just a little bit up into Ophiuchus, or maybe just down from the bottom of Ophiuchus. That gets around Theta, Ophiuchi, are the three. It's sort of like got a couple stars around Theta, Ophiuchi in the middle there. So you find those, and then through binoculars you can actually see that. But that's where that area of the sky is. And it is just a spectacular area to explore when you're under the darkest skies. Just with a simple pair of binoculars, just to be able to see that out. And I didn't discover that or anything. I always had seen like some dark rifts in the area, and kind of had grown up with it. But it's when I observed with former Sky and Telescope editor Alan Whitman, who's originally from my area, that he pointed that out to me and told me about it, and subsequently wrote some articles in Sky and Telescope about it. So it is really neat to be able to see these things for ourselves. When we can get out there to dark skies, and hopefully as people are getting out, I know camping's being really big this year, it seems. So hopefully people will be able to go out, maybe if they are getting out to these places, even if they don't have, they don't need to take a chart, don't need to take really anything. If they have binoculars, that's great, but you don't need them. You can go out and then just start taking a look at the Milky Way for yourself. And the skymaps.com charts that people can print off, those actually have the Milky Way banded in on them. If you kind of want to do some of that exploring, just make sure you use a red flashlight or red down a regular flashlight. Pretty good with some red nail polish, or red duct tape is always my favorite. So
yeah, for sure. And if anybody purchased the Sky and Telescope Pocket Atlas, which is one that we've recommended on a couple of our episodes,
it's excellent.
Just look up Sagittarius. If you plan on panning through the Milky Way with your binoculars, look up Sagittarius. Sagittarius will be kind of lower on the horizon in the Milky Way, and that can kind of guide you to a whole bunch of different objects to see within that Milky Way.
Mm-hmm. Yeah, exactly. So I'm just looking here at my notes. Shane, do you have anything else to add about the Milky Way galaxy?
Just that I'm excited to see it in a couple of weeks when we go south to grasslands.
Yeah.
And binoculars of, any flavor will work. Like, we've used those little 2x42s that we, kind of crafted together with some 3D printing.
Mm-hmm.
But anything else, any other binoculars work as well. Like, it's just a fantastic place to pan through with two eyes or with a telescope. And you'll get a lot of enjoyment out of that.
Yeah, very good. All right. Well, yeah, I'm good too. It's one of those things where it's sort of pretty simple to describe. Looks like a band that runs from the southern horizon up overhead, and then down into the north. It just looks like this sort of whitish band of clouds with stars in amongst it. That's what it is. That's what the Milky Way is. And if you do get somewhere dark enough, like even if you just pull off on the side of the road somewhere at like a look-off point, sometimes you'll be able to see it. But if you do get somewhere dark, and especially if you have a pair of binoculars, it's amazing just to kind of sit in a lawn chair or just kind of put a towel down or a beach towel down on the ground, and then just kind of scan throughout that Milky Way. That really is a very, very awesome experience.
And maybe I'll add one other thing, Chris.
Sure, yeah.
We've talked a number of times about getting to a dark sky. And people might be wondering, well, where are these dark skies? How can I find a dark sky?
Oh yeah, that's a good point.
One thing to look for, just Google this, is dark sky preserves. It's a designation that a lot of national parks, or I shouldn't say a lot, but some national parks have acquired. And if you go to one of these areas that is a dark sky preserve, what that means is, and really, you should probably be doing some of this explaining, Chris, because you've been quite involved in acquiring some dark sky certifications for
you're doing a good job.
Some areas.
Doing a good job, yeah.
But basically, they have to adhere to certain lighting standards, which includes having as little lighting as what's needed. And then any lighting that is there, it has proper shielded covers so that the light doesn't shine up into the sky, that the light itself isn't too bright, or that it, maybe is dimmed during certain hours of the night. And, these are great places to go to find a dark sky and, look at things like the Milky Way or these other objects that we've talked about.
Yeah. Yeah, no, exactly. And, it really is important to us to have these sponsors like the National Park System here in Canada. Parks Canada, it has been a great partner in helping to create these as well. I know in the States they have a variety of other organizations. Now they have the International Dark Sky Association, which is based out of, I think, Arizona, and has also been involved. There's also several dark sky preserves that have been created in America, and then I know over in the UK. They've got a few that they've created as well. I think one of the biggest ones and one of the earliest ones is over in the UK. So these are really great places to go, and really fortunate to have these. And especially here where we have one only 2.5 hours away, and it probably is about one of the darkest ones that has been created so far. So we're really lucky to have that.
Yeah, we are. I can't wait to get back.
Yeah, good stuff. Well, unless you have anything else to add, Shane, do you want to tell people how they can stay in touch with us?
Sure. You can find us on Twitter at Actual Astronomy is the handle. And what we're going to try to do is, as we talk about things in the podcast, we'll put more reference material there so you can kind of get an idea of what we're talking about. So, for example, last episode I was talking about solar observing. I posted a picture of my little solar telescope so you can see what that looks like. We also talked about the comet Neowise on the last episode, and I retweeted some imagery of that. So, go check it out. It sort of supports what we're talking about, gives it a little more context. Plus, you can also send us messages or ask us questions there. And you can also reach us. We are actualastronomy@gmail.com if you want to send us emails.
Sounds good. All right. Thanks so much, Shane. We'll talk to you soon.
Yeah, thanks.
All right. Bye-bye.